So here's the problem, is these equations, these functions weren't set up to answer that question. There's something wrong with them. Basically, if you look at the graph of this revenue function, there is no maximum on the graph. But what I need you to know is that when you're looking for the maximum, you're looking for the highest point, and then it's either a y or an x value at that point. Since we're talking about the maximum amount of revenue, which is y, you would be looking at the y value. Now this next question says how many computers must be sold to reach the maximum revenue. So how many computers, that's now the y value. So again, you're going to that highest point, but the answer to this one is the x value. All right, average rate of change. So the idea behind average rate of change is you need an x1 and a y1, an x2 and a y2. I'm not calling them x1 and y1 though, I'm calling them a and f of a, b and f of b. You're given a and b in the problem, you have to calculate the f's. So a ball is thrown vertically upward from a roof, blah, 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 20 meters high. The equation which gives its height is this stuff. And it says calculate the average rate of change, slope, of the ball between 1 and 4. So automatically you should know that A is 1 and B is 4. Now if I want to find f of A, that means I have to do f of 1. And what that means is in this function up here, everywhere there's a t, I got to plug in a 1. Right? Whoops, not t, it's a 1. Okay, boop, boop, boop. We'll get that value in a minute. So down here, to find f of b, that means find f of 4. Calculator and all that stuff. Okay, there's my values. So in order to find my average rate of change, I've got an x1, y1, x2, y2, and I need to find the slope. So average rate of change is going to be f of b, negative 46.4, minus f of a, 18.1, over 4 minus 1. Okay, so I did calculations. I got negative 21.5, and that's in meters per second. Now, average rate of change can be negative. It's negative because this ball is going downhill, right? It's thrown from clear up on top of a school, and so it's always going down. Well, it's going down at a rate of 21.5 on average meters per second. Okay, same thing here. Okay, this last problem is asking which one has the greatest average rate of change, right? So we've got 3 functions here. We've got f, g, and h. And it says over the interval from 1 to 5. So for every one of these, a is going to be 1, b is going to be 5. A is equal to 1, b is equal to 5. A is equal to 1, b is equal to 5. And essentially what we're doing is we're trying to find the f values for each one of those. So I need to know what f of 1 is, because I'm looking for an x and a y, x1, y1, and an x2, y2. Since average rate of change is just slope, then if I have these two things, I can plug it into the formula that I know, and then I don't have to worry about the f's and stuff. Well, this is given to you, that's going to be your x1. So this is going to be your x2. Now you have to find the y values. Well, for this problem, you have a y equation. It says take your x, plug it inside, so 1 minus 3 squared plus 1. That ends up being 2 times, that's negative 2 squared, or 4. So it looks like this guy, f of 1, is 9. Okay, now let's do it for b equals 5. We need f of 5. Same idea, you're going to plug in a 5 where the x is. Whoops, I forgot the plus 1. Plus 1. Okay, that's 2 times. 5 minus 2 is 2 again. Squared is 4. Looks like this one's also going to be 9. Okay, so our average rate of change, our slope, is going to be 9 minus 9 over 5 minus 1, 0 over 4, or 0. Okay, moving on to G now. This time we're given a table, but we still need to fill out those points. When x is 1, what's y? When x is 5, what's y? So a equals 1 means we're finding g of 1. But in the table, it says when x is 1, g is negative 2. So that's the number here. All right, next time we want to find g of 5. Looking at our table, that's when x is 5. That is what g is. Okay, we got our 2 sets of coordinates, x1, y1, and all that fun stuff. Average rate of change is going to be -8 minus -2 over 5 minus 1. Okay, that's -6 over 4, or reduced, that's -3 halves. Okay, this last one. Let's do orange. This time you're given the graph. You still have to find those points. You still have to find, whoops, it's h, not f. H of 1 and h of 5. Now, as far as a graph is concerned, that doesn't make a lot of sense because it's the graph. But if you think of it in terms of x1, y1, basically I want you to look at the graph and fill in the blanks there. When x is 1, what's the y coordinate? All right, well, here's x is 1. Looks like the y coordinate is 0, right? That describes that point on the blue graph. How about 5? Over here, when x equals 5, if I go up to the graph, right there, looks like the y value is 6. Okay, average rate of change, 6 minus 0 over 5 minus 1, 6 over 4, or positive 3 halves. So it looks like h of x is the greatest average rate of change.